but none of them are exactly centered. So you're kind of using those all to push the whole wheel to be centered on the assembly. But so in other assemblies, you're doing mechanical stuff, you use like one countersink and the rest counterbore. Because in that one countersink positions that one critical thing, and the rest of them just tighten it down. But if you want to use more, then they'll all try and fight. So the order that you tighten those will determine how it kind of fits on.
But this is not for very, high tolerance positioning, right?
It's for all positioning.
But I mean, if you really want to be precise, you'd want to use some type of pin to locate.
And then use other counterboard.
But more like manual assemblies and this countersinks work great to center your parts. So again, with the countersink option, we have the different hole types we want to make. Again, simple if you just want to manually edit your countersink in the dimensions that you want. Clearance, again, if you know the type of screw that you're going to be used, it'll take those standards into account and create the clearance depending on the fit that you choose here. And then tapped, it works the same way for counterbore, countersink. Depending on the screw that you're going to use, it'll give you the exact dimensions to take into account those thread minimum and maximum sizes for your screws. And again, it works the same way as a counterbore. You have the different 3 options here. There's also another tapered option, but that's very, we're not going to be using them often.
Does anyone know when you do use tapered threads? It says it right there.
Piping.
Yep, pipes. Pipes use tapered threads, nothing else. So
and then
pipe nipples or fitting, stuff like that, that's when you use tapered thread. Otherwise, it's all straight threads.
And then lastly, just the drill point that we're going to be using. Again, it can be it depends on how you're creating this hole in the manufacturing process. If you're drilling it, you want to specify if it has a drill point, if it's a blind hole, right? If it's not going through the hole of the material, you are going to have an angled point. And that's something that's good to represent and take into account, especially for manufacturing purposes. If it's a blind hole, you don't want to create a hole where you don't want to go all the way through, but you don't take into account the point and it protrudes, right? So you have to consider that you do have a point, and in case the call out is that you don't have a point or an angle for your hole, this involves a different type of manufacturing process where either you use a flat bottom drill or you come in afterwards with a flat bottom tool to create that flat bottom onto your hole. That just adds extra cost to the manufacturing process and it's not always necessary. But say you do want to have a pin to position your part to another one, you would want to have a flat bottom hole so that it sits better and it has more contact area inside that hole. That would be one option, to use the flat drill point for your holes. But for 90% of our applications, we'll just be using this if it's a blind hole, and if it's a through hole, then we don't worry about the type of tip. It'll always go through, so it doesn't matter if it's a 118 degree, if it's a 140 degree, it'll go through, so we don't have to consider that. So anything I might have missed?
You go over the different extents options through all of the surface.
Oh, sure. This works in the exact same way as in the extrude operation that we already saw. You can define a distance, or you can select up to which surface you want to create that hole. To it's not done. It's referencing something else. It's referencing the part. but this would adjust to, if you make any changes to your actually body, it would adjust to that dimension, right? So you don't have to come back and edit the distance. You can also edit to 2, or just through the whole material. If you start adding more parts, it will actually start going through all of them. Again, it works the same way as the extrude function.
And did you do partially threaded holes, not fully threaded?
Sure. So here, when you defined if your hole is going to be threaded or tapped, you can define a distance to do that. I forget, I keep using enter. And so here, when you select your tapped option, you will get these other two new options as well for this type of thread, or you can do a full thread or just an offset thread if you don't want the thread to start at the very beginning. You just want it to engage at the top. Again, it'll give you the dimensions here of what the offset is going to be, what the length of the total thread is going to be, and this one does take it into account from the very top. So it would just be like a subtraction here between the offset and the total length. So if you wanted to start from the beginning, the offset would be 0, and then the thread would be up to 1 inch. And you can start seeing here, it doesn't show it directly, but it shows you this is where the thread goes up to because we selected 1 inch deep. You can start modifying it here. But again, it's just a matter of if you want to do an offset to that thread.
So if you go back to the canvas page, scroll down a little bit. So you can see there on the left hand side, the first one, the thread starts at the top and goes down and stops short. On the second one, the thread goes all the way to the bottom. So the difference in that is that depending on how it's being made, there's different ways to make it. If you're using just a tap doesn't thread all the way to the end. It leaves 4 to 5 threads unthreaded, and you want to stop above the part. If you're doing another mechanism like the thread mill, then you can get to all the way to the bottom, but it takes a little bit longer than using a tap. Or you have to come back, tap it with a regular tap, then come back to the bottom and tap. So usually going all the way to the bottom takes a little extra time. So usually you want to leave that little bit of space. So you'll see that on the drawings. And so if you look at the call out for the thread, that the depth is 1/2 inch. That's 1/2 inch is a good thread. The hole is actually deeper by about 4 to 5 thread lengths. Okay.
So yeah, that's true. That's a very important consideration to have, especially when you're designing machined holes and threads. Normally, you have to use a drill bit to drill your hole first, and then you come in with a tap to create the threads for that hole. But taps come in very different shapes and sizes and different point tips, where sometimes the tip is longer than your thread, so you don't want to have your thread go all the way to the bottom, because then your tap is going to reach the bottom of the hole before it creates all of the threads. So normally you create these offsets so that you give enough space to your tap so that it can reach all the way to the bottom and create the threads that you need up to that point. But you need to have some clearance space to let that tap go all the way to the dimension that you need. There are some taps that are much stouter on the tip, and then those you can push all the way to the bottom, like in here on this figure. But they're a bit more expensive. They're a bit more difficult to start, defining the depth that you're going to them. Most standard taps will have a longer nose tip, so you have to consider the length of the tip of your tap to allow it some space to actually reach to the bottom. Again, this is more tied to machining processes, but that's one area where you would have to really think about the space that you're giving your tap to create those threads inside a hole. Because again, if you don't take that into account, you can drive your tap all the way to the bottom, and you can start snapping those taps inside your hole. So you have to consider what tools you're using for the design that you're creating.
And we'll talk more about how to read the thread notes later on. But kind of as you look at the thread notes there, the first number is the diameter of the thread. The second number is the thread per inch for the inches, or in the metric one, the space between. But that's just kind of the designation of the thread for now. Later on, we'll talk more about threads in depth. But for right now, the important thing is the first number is the diameter of the thread. Okay? So that's what those are numbers are how you pick the thread off the dollar. Yes, sir.
So that was kind of my question. What in these dimension descriptions tells us that the thread is only so deep?
The depth. So that whole symbol with the
Yeah. So here the symbol, the
line and arrow down?
yeah.
Yep.
I thought that was the depth of the hole.
So if it's a hole, it's just the depth of the hole. But if it's a thread, that's the depth of the given threads.
So what tells you how deep to make it?
So on this one, the hole is going to go 10 millimeters deep.
Right.
Because it shows it's going to the bottom. On this one, this is the 1/2 inch. This is 4 to 5 threads deeper.
But what tells you that in the dimensioning description?
So the 0.5 tells us this, and then this is just extra. It's undimensioned. That's for the machinist to figure out what they want to do.
Oh, okay.
Because
Okay.
this is telling them that you don't care how deep this is.
Okay.
Make 1/2 inch of good threads and have some hole at the
I
end.
see.
Yeah.
Okay.
You can do a dimension, and so we can call out the depth of the hole, and the diameter of the tap drill, and then the thread, but you don't have to.
If it's not crucial.
If you don't care about exactly how deep that is, you call out how deep you want the threads. Let the machinist make the rest of the hole according to what's gonna be good for their process. Don't micromanage.
Yeah.
Call out what's important.
If they give me a design and say, hey, I just want 1/2 inch of thread, then I'm like, okay, then I'm just gonna drill through the whole thing. I'm not even gonna think about it, and then I'm just gonna focus on making it the threads 1/2 inch. Right? But yes.
And you can see from there, they can't go all the way through, but they have to stop short. But where they stop short doesn't matter.
Okay, that makes sense. Thank you.
Did you show making a concentric hole?
No, but that is directly through like on a feature.
So yeah. So if you want, or if you, so kind of one thing is make sure you don't have a bunch of extra sketches turned on, so that way they don't get confused. But if you have some kind of a round feature already, let's back a little bit, and you want to make a concentric hole, that's the only time that I use it without a sketch. So you can pick on the face that you want to put it, and then pick the edge, and it'll make a concentric.
Oh, okay, that's useful.
And then you can go in, and if I edit this fillet here, you can see
Man, I could have used that last semester. Oof.
the hole stays concentric. I showed you that last semester.
You probably did, but I must have missed it.
You can also do.
And so you can see as I bring that in, that hole, it stays concentric with where that radius is. So that's the only time I use a hole without a sketch ahead of time. Every other time I'll always make a sketch, put in a line or whatever. Is it good to just now make my holes, or what should I do? Yeah, I need to dimension it, right? I can't just leave a blue line sitting there. And now I can go in, add my hole, pick those points, and tell what to do. So anytime that you have a screw going through it or something, make it a clearance hole. And if you want to do a counterbore, countersink, you can do that from there. It's okay. And for those, it's going to go through all. Because having a counterbore hole that stops there in the part doesn't really do anything. It's going to go through to something else. If a screw's going through it, it has to go through. It's kind of making a blind counterbore hole is kind of useless, except in certain cases. There's occasionally where you might be using a a set screw of some kind that you want to have it going, but it's still going through to another hole or something else.
It's the whole water. With a
but-
really wide counterbore hole.
But yeah, so that's kind of where we'd go. But make a sketch, do it. Even if the sketch is just 1 point, do that. Don't draw the circle on the sketch, because a lot of people will do that. They'll draw the circle to try and use the center point of the circle for the location of their hole. If you just need a single hole, just create a sketch, add a point, and now dimension that point. So I can even dimension from that line to there and tell it how far to be down. And now I can add in a hole on that point and get it going. It's over here. Okay? So we always want to make a sketch. If you're not making concentric, use a sketch. And if it's just 1 point, use a point. If you're doing one hole, use a single point, put it in there. If you're doing multiple holes, you can do multiple points or do lines and then use the endpoints of those lines. Okay? So does that make sense? Questions? So don't draw a circle and extrude it if it's a hole. Okay? That is my biggest pet peeve. Because if you do that, you automatically get a flat bottom hole, right? And as Emmanuel just said, that costs more to make than one with a point. If you try and extrude it down and straight and then try and add the point manually, that's way more work than using the hole command, right? So use the hole command, do it the right way, right?
I did have a question.
Yeah.
Is there a way to, in a sketch, just automatically select all of the points, or do you have to select?
Just pick them all, yeah. It's not automatic, actually, it might be because you guys.
There's just other softwares that I've seen, you can do multiple points, and you just select the sketch, and it'll select all of those points inside the sketch?
No, but that's also in SolidWorks why you can't do a center rectangle as a pattern, because it's automatically going to pick that center point. You can't unselect it. So yeah, depending on the program, how that works is different. Like in Inventor, you can specify center points and non-center points, and then it'll automatically select everything you've indicated as a center point. In SolidWorks, it only has one type of point, so it automatically picks all the points, and there's no way to unselect any of them. So if you try and use like a center rectangle, it automatically puts a point in the middle to kind of line up the whole thing, and it'll always put a hole there. And there's no way to undo that. And so you can't use a center rectangle to center a pattern of things in SolidWorks, because it's automatically going to pick that center point. And here you just manually have to pick all of your points. But you shouldn't be doing, I mean, if you've got a big pattern of things, it's better to make one hole and then pattern it, which we'll get to later. Like if I had 10 holes in a row, we'd make one, say, copy this one 10 times at this distance. We wouldn't make a sketch with a bunch of points, because then that would be over 6 things in a sketch, right? Isn't that my rule? So keep your sketch simple. There's other ways to do things when we get to making things simple, okay? So you shouldn't have to pick a bunch of different points for holes, because you need to make it easy. Okay? Any other questions? No? All right. You've been going for about an hour. So let's do a break now. And then after the break, we'll do did you guys do the bamboo groups at all? Did you talk about that?
No, not yet.
No. Then we need to break up into the groups for the bamboo printers, and I'll kind of give you the brief intro of that. As well as I'll go over the kind of the final exercise. I didn't make the exercise for the holes. I'll probably make it and you can come back to it, but it's going to be making a bunch of holes. So practice doing that. I'll probably still make it this weekend. I plan on spending all day tomorrow and Sunday working on this stuff for this week and getting next week's stuff ready for you. So you're still going to do that. But I did turn on the exercise for this week, and so I'll go over that. It does have some holes in it, so and we'll kind of talk about that after break, okay? And then you also have your standards discussion to do. So that's going to be a good part of today's stuff, right? All right.
Mr.